Now we get to the greatest integer function. You remember how we graphed those, right? So the domain is going to be negative infinity to infinity. The range is going to be the set of integers. It's never increasing and never decreasing, but it is constant on the intervals n to n plus 1, where n is an element of the integers. We're going to say this one is not symmetrical. Just like all of those other functions, if you subtract 4 outside the function, it will shift it down 4. So we're going to shift it down 4 units from here. 1, 2, 3, 4. It would look something very similar to this. It's a little bit off, but I think you get the idea. Now if you add 2 inside the function, it would look something like this. It's going to shift left 2. So it goes from here, 1, 2, and it would stop there. Left 2 units. Finally, if you put the negative in front of the function, it's going to reflect it over the x-axis. And if it reflects over the x-axis, it looks something like this. Now we're going to talk about stretching and shrinking. I will let you read these words, but let me just give you an example. Let's start with the function f of x is equal to x squared. Let's call this the parent function. If you put a number here that's not between 0 and 1, so it's not a fraction between 0 and 1, that's going to make your graph tall and skinny. So if this graph looks like this, then this graph would look like this. It would just be tall and skinny. And if you have a coefficient that is between 0 and 1, it would make it short and fat. So it would make it do something like this. I did exaggerate those just a little bit, but that's what that means. So let's put all of this together and try to sketch this graph. We're going to do it in several different little pieces. First of all, I look at this and see that I have a square root function. So because of that, I want to graph the parent function first. The square root function looks something like that. Well, what if I add 1 inside the function? That means I shift it left 1 unit, right? And what if I put this 2 in front of it? That stretches it and it makes it tall and skinny. So something like that. What if I put a negative in front of that 2? That would reflect it over the x-axis. So it's still tall and skinny, but it's upside down. And then what if I added 4? I say add 4 because this 4 is positive. If I add 4, I take this graph and I shift it up 1, 2, 3, 4, something like that. Still tall and skinny, but upside down. So this would be the final graph of your original equation. So how do we write the function if we are given the transformations that it does? In these problems, we're going to use this function and we're going to perform these transformations. What we have to do is come up with the new function. So the graph of f of x is shifted up 5, left 7, stretched by a factor of 3, and then reflected over the x-axis. So if we start out with our absolute value function, and we shift it up 5, that means plus 5 on the outside. Left 7 means plus 7 on the inside. Stretched by a factor of 3 means we put 3 here. But then after all that is done, it is reflected over the x-axis. So you could clean this up a little bit and make it look like this. -3, absolute value of x plus 7. Distribute that so it's here and here. So -5. This would be your new function after the transformations have been done. So what about number 2? The graph of f of x is reflected over the x-axis. Notice how it says this first, and here it said it last. That's really, really important. So it's reflected over the x-axis, shifted up 5, shifted 7 left, and then stretched by a factor of 3. So we start with our function, reflected over the x-axis, so we put the negative there. Then it's up 5, 7 left, stretched by a factor of 3. This is your final function. Now we get to talk about symmetry. What I want you to remember is that an even function is symmetric about the y-axis, and an odd function is symmetric about the origin. Okay, so what exactly does that mean? For an even function, if you were to be able to plug in a negative x into your function and you get the original function back again, then you have an even function. So if we have something like f of x is equal to x to the 4th, and I want to know if it's even or odd, I just plug in a negative x. When I raise a negative to an even power, I get a positive. This is exactly the same as what I started with. If that happens, then I have an even function, and an even function is always symmetric about the y-axis. So you do the same thing for an odd function. Let's say we have f of x is equal to x to the 5th. I want to know if it's even or odd, so I plug in a negative x. When I raise a negative to an odd power, I get a negative. And this is exactly opposite what I started with. If you get exactly opposite of what you started with, then you have an odd function, and it is symmetric about the origin. So let's determine if these are even or odd or neither, and what their symmetries are. So you always substitute in a negative x everywhere there is an x. When you raise a negative to an odd power, you get a negative, and a negative times a positive is a negative. So negative 5x cubed plus x. You could probably look at this and tell, but I want to go ahead and factor out a -1. That would give me 5x cubed minus x, right? Have a look at this. Is this exactly the same as what I started with? It is, and here I have the opposite of that. It's exactly opposite what I started with. If that happens, then I have an odd function, and it is symmetric about the origin. Opposite, odd, origin. The 3 O's. That's a good way to remember. How about the next one? Substitute in a negative x. So the absolute value of negative x, is that really the same thing as the absolute value of x? These two really mean the same thing, right? So this is exactly the same as what I started with. If it's exactly the same as what I started with, then I have an even function, and it is symmetric about the y-axis. How about number 3? Substitute in a negative x. Simplify. A negative to an even power is positive. Negative times negative is positive. Now have a look at this one. Is it exactly the same as what I started with? X squared is positive, but 3x is negative here and positive here. 6 is positive. It's not exactly the same. It's not exactly opposite, which means it's neither even nor odd. Now this is quadratic, so it is symmetrical, but it is not symmetric about the y-axis, nor the x-axis, nor the origin. So for now, we're going to say not symmetric, because we're really only dealing with those 3 things right now. Okay, finally the last one. Substitute in your negative x. A negative to an even power is positive. So negative 2 times a positive x squared is a negative 2x squared. Is this exactly the same as what I started with? Yes, it is. So that means we have an even function, and it is symmetric about the y-axis.